AREA is the Air Conditioning and Refrigeration European Contractors Association, been in existence since 1988, currently 22 members from 19 countries. I'll not go through the figures because they're up on the screen. Our members essentially represent the businesses responsible for the design, installation, maintenance and repair of all types of refrigeration, air conditioning and heat pump equipment. And it's important to remember that heat pumps are not a particularly new technology. I think there's been quite a lot of mention about heat pumps today, and this is really about a technology breakthrough conference, but heat pumps have been around for a long, long time. My own company have been installing heat pumps for 20 odd years now. The main priorities for AREA at the moment: the review of EC 842/2006, better known to those of us in the industry as the F-gas regulation. Energy efficiency, of course, it's probably the most important thing affecting all aspects of life, not just in business. Low GWP refrigerants and optimised use. We've heard a little bit about some of these alternatives this morning. And the RES directive we've heard a little bit about as well from Andrea just a couple of speeches ago. Our specific interest in the RES directive, of course, is with heat pumps. Heat pumps are extremely important for our members for obvious reasons. As I've said, we're the principal designers of these systems, and we have been for a very long time. There's been a steady growth in the numbers of these systems that are out in the field, and the high efficiencies achievable are clearly in line with the overall AREA objectives and aims. And the recognition of this technology as a genuine renewable energy source has the potential to significantly affect our members' businesses for many years to come. But the rapid growth and widespread use of heat pumps has naturally brought with it numerous problems. Some bad publicity was published late last year by the Energy Saving Trust, but it was mentioned again this morning. They'd carried out a year-long field trial on a number of domestic installations. Poor design, poor application, installation, commissioning procedures, lack of maintenance. A combination of these factors were all clearly to blame for the poor performance figures revealed. It's not out with the bounds of achievement to realise actual field results with standard air pumps, standard geothermal heat pumps, with physical measured COPs in excess of 6. There's been some mention about COPs in this morning's session. I can back up the COPs in excess of 6 because rather than abiding by the Energy Saving Trust doing their field tests, I had commissioned Mitsubishi Electric to do a full survey of an installation that my own company designed and carried out at the Castle Course Golf Course in St Andrews. And that again was a year-long trial. And we had COPs up to 6.4. The secret in achieving the high COPs that are achievable, though, is in ensuring that the systems are properly applied, the right equipment for the right job. They're professionally installed, and then they're commissioned correctly, paying proper attention to detail. The results are an extremely efficient, stable climate-controlled building with a very low carbon consumption rate. So obviously the continued growth of the heat pump market is something that we at AREA feel very strongly about. But that growth has to come hand in hand with an increased level of professionalism at all levels. The installation standards have to rise. They must improve if we are to achieve the efficiency levels that the manufacturers claim are possible. And this only comes about with an equivalent raising of awareness at installer level. Not just awareness of installation techniques themselves, but of the equipment itself. A better awareness of the technology and how it works. There's been a worrying trend in recent years of a kind of dumbing down of education at the vocational level. And this trend hasn't been helped, the contractors feel, among the technical or vocational trades by manufacturers making their systems in such a way to make it very easy for non-technical people to install them. It doesn't really help anybody in the long run. It's hard enough trying to persuade contracting companies during a time of massive recession that we've had in the last 18 year to 18 months. It's hard enough trying to persuade them to train operatives properly when they know that they're being undercut by the cowboy industry, the cowboy sector, that can buy equipment with very little checks or balances made on it. What the industry clearly needs is a European-wide certification programme that takes into account all of the necessary skill sets. QualiCert project is certainly a good starting point. The work that the European Energy Centre are doing in launching this centre here is a fantastic step forward. But all of this needs to be combined with the full F-gas qualification, as well as full and effective training in alternative refrigerants such as CO2 and hydrocarbons and other low GWP alternative refrigerants, to make sure that anyone in our sector that they fully understand not only the benefits but also the pitfalls that come with many of these, whether that be high pressures, flammability, oxygen displacement, or whatever. As things stand at the moment and for the foreseeable future, in the small to medium duty market, and in particular the domestic market in the UK, the vast majority of heat pumps utilise HFC refrigerants to realise their low energy potential. It is true that in larger duty systems, we can harness the excellent efficiencies of CO2 or ammonia, particularly in the northern European countries, less effective in Italy, and I know we have a very high proportion of Italians here today, so maybe less relevant to them. But for it to be applicable in the UK domestic market, we're using CO2 in particular, or ammonia, we would have to have a wholesale change of culture, and would need to embrace concepts such as district heating. There's a couple of sessions this morning have mentioned district heating systems, central plant systems. Very common in some parts of Scandinavia, but a totally alien concept to many UK building designers. In the meantime, we're left with the reality that the higher GWP HFC refrigerants are the best heat transfer fluid for the domestic market. But of course, the HFC gases have an equivalently high GWP, global warming potential, and they're under attack from some quarters, not surprisingly. There is a general feeling among political groups that a measured phase down is desirable. Certainly there are applications where alternatives can be used effectively and even more efficiently, and the growth in use of CO2-based systems at supermarkets in particular throughout Northern Europe last year is a testament to our sector's ability to adapt and evolve. This growth has seen a natural phase down of HFCs where practical, without the need for any draconian legislation, forcing the market to jump one way or the other. This has allowed businesses to look at the bigger picture and to evaluate the pros and cons of moving to low GWP refrigerant systems based on proper business modelling data rather than artificial modelling. But it's absolutely critical that if we're going to retain the use of HFCs in the medium to long term, where they're most efficient, then the gases have to be contained. If a gas stays in a leak-free system, and if it's properly installed, there's no reason to expect leakage. If a gas stays in a leak-free system, then the GWP is equivalent to zero. It doesn't affect global warming at all. It's only a greenhouse gas when it's leaked out to the atmosphere. The only way we can improve the leakage, though, is to raise the overall standards, as I've said. Certification of heat pump installers must be intrinsically linked to the F-gas qualification to guarantee high levels of professionalism in the industry. The training has to identify weaknesses in the student's background knowledge and address these weaknesses. If an installer doesn't understand how a system works, they cannot possibly understand all of the potential pitfalls when designing, installing or commissioning them. The skill levels identified as necessary, components of an RACHP installer's knowledge set outlined in the EC-funded Leonardo da Vinci Refrigeration Craftsman project, is a bit of a mouthful, I understand that. It was carried out by ARIA some years ago, and it incorporates all of the details needed to understand the principles of all refrigeration-based work, not just air conditioning or heat pumps. And we feel that this should ultimately form the foundation of any training in our sector. With regard to the existing legislation, EC 842, the F-gas regulation, it already states that all stationary refrigeration, air conditioning and heat pump equipment must be installed and worked on only by properly qualified personnel. The law already exists, even if it hasn't been effectively implemented yet. So if the law requires this fundamental knowledge to be proven and certified, it makes sense both from an educational and a business perspective to make sure the full extent of the F-gas certification is incorporated into the heat pump certification process. Ultimately, there are no winners if there is a continuation of the dumbing down of the installation or commissioning side of the heat pump sector. Lower quality installation engineers who don't understand how a system works or know nothing about the thermodynamic or physical properties of refrigerants being used do not understand the importance of properly evacuating a system, the dangers of leaving moisture in a system and how it affects oil quality, accelerates wear in the compressor and ultimately leads to compressor failure, expensive compressor failure. The lack of proper certified installers inevitably leads to unreliable, leaky systems. We all know it, we've all seen it as contractors, we've all been called out to repair poorly installed or poorly maintained systems over the years. But the problem is that poorly applied or poorly commissioned systems give the false impression that heat pumps are no good. And that is a fallacy that's not helped by alarmist publicity that was generated from the Energy Saving Trust report. Publication itself wasn't alarmist, but the way certain people have reported it and quoted it has been unhelpful, to say the least. Heat pumps are an excellent renewable technology. We've heard that several times today already. They are reliable, they're efficient, and relatively cost-effective. But they have to be designed and installed by properly qualified people. If the heat pump is of the monoblock style, where the refrigerant or heat exchange circuit is hermetically sealed at the factory and no field connections are required, then, okay, we would accept, obviously, that you don't need to be qualified in refrigeration work. But many of the systems are of the split type, where you have piping that's connected in the field that must then be properly evacuated. It must be installed by a professional. They have to know what they're doing. They all become essential if the intrinsic efficiency qualities are to be fully harnessed. RE are currently discussing options with other stakeholders across Europe and the wider world to decide how we can best achieve this. Again, the F-gas regulation provides an easy answer. It is an offence to take delivery of the gases, the fluorinated gases, if you do not hold the relevant certificate. But this part of the regulation is dependent on a fully regulated supply chain. Reality tells us a different story, unfortunately. Some supplier wholesalers have been known to sell F-gas containing equipment and bottles of gas itself with no checks done whatsoever. And the ease with which non-qualified, non-certified people can buy fully charged split systems over the internet is quite shocking. My own company has taken numerous calls in recent years where householders and end users have bought and installed small air conditioning and heat pump systems, then had to call out the professionals because they didn't know how to evacuate or pressure test, and the entire gas charge has been contaminated at best or leaked out entirely at worst. Stricter controls on supply have been met with negative responses by the manufacturers who understandably complain about the supply chains being disrupted. So the logical solution as we see it, the way that we can quickly and easily tick all of the boxes and achieve what everyone wants in the end, which is workable and effective F-gas regulations, is to stop supplying split system heat pumps pre-charged with the gases. Our industry manages to install refrigeration systems perfectly well, very little of which comes with a refrigerant gas pre-charged. So we certainly don't need our heat pump and air conditioning systems to come pre-charged. There's nothing to stop any end user still buying a heat pump and installing it themselves. But the difference is that if we go down this road, they would be able to do all the installation work, thus save themselves a lot of cost. But they wouldn't be able to put the system to work. They would have to get a professional installer to come out to put the gas in and put the system to work. And any responsible refrigeration contractor is not just going to turn up on site and put gas into a system. They would first pressure test the system. They would then evacuate the system properly, and then they would charge it accurately. The gas bottles themselves can only legally be supplied to qualified people. So by stopping the pre-charging of split systems, we can make sure that they are installed optimally with the correct gas charge to optimise energy efficiency. The European Commission consultants, just to conclude, have estimated that some 30 million domestic heat pumps will be installed in the EU by 2020. If they are properly designed, applied, installed, commissioned and maintained, then we can go a long way toward achieving the carbon reduction challenges and the 2020-20 commitment that we have set ourselves. Thank you.